Now we're going to talk about the second part of section 2.4, which is a library of functions. These are all functions that you need to know. You definitely have to know them. You need to know them, what their graphs look like, and their domains and ranges, because we're going to be using them throughout the rest of this semester as well as in calculus. So the first one is what we call a constant function. A constant function has equation f of x equals b, where b is some real number. So it's a constant, not a variable, it's a constant. Yeah? You may recognize this, that f of x is y. So if you had something like y equals 5, that would be considered a constant function. The graph of a constant function is a horizontal line through the constant on the y-axis. Right? That works because every point on this graph has y-coordinate b, and that's what satisfies the equation. Yeah? Its domain is all real numbers, and its range is just b. You only get that one output. Any input that you put in, right? So let's pick something random like 5. We're going to get the point 5b there. Yeah? So that's why its domain can be anything and its range will only be b. The second function we call the identity function, and it has equation f of x equals x. Now this is kind of a funny looking one, and sometimes it confuses students, but the idea is that you plug in x, and you get the x back out. So you get the same inputs, the same outputs as inputs. If we were to make a table for this, if I put in a 1, I get out a 1. If I put in a 0, I get out a 0. If I put in a -1, I get out a -1. So when we end up graphing the identity function, we end up with a point at 0, 0, a point at 1, 1, a point at -1, -1, and I could see as I keep going I would get a point at 2, 2, and 3, 3, and -2, -2. Basically my x-coordinate is always going to match my y-coordinate. So this creates a line, right, with slope 1. From each point to the next point, we go up 1 and over 1. So it's a point that goes through it's a line through the origin with slope 1, right? It's always increasing. Yeah? What's its domain and range? Well, its domain is all real numbers. It is a linear function. So domain has to be all real numbers. And because every input that you put in gives you the exact same output, our domain and range are going to be the same, so that means our range is also all real numbers. The next function that you need to know all about is the square function. The square function. The square function's equation is f of x equals x squared. Yeah. So this is a parabola. It has its vertex at the origin. You're probably familiar with it. It goes through the points 1, 1, -1, 1, 2, 4, because if I square 2 I get 4, and I also get 4 if I square -2. So we have this parabola like this. I like to think of this as the most basic parabola. It's an even function. It is symmetric across the y-axis. Its domain is all real numbers. Notice if we look at its graph, any x we can find on the x-axis is going to give us a y. But its range here only gives us positive numbers and 0. Because if we square something, all we can get is 0 or a positive number. The fourth function that you need to know, the book calls it the fourth function. Sorry, I forgot about the number. The book calls it the cube function, but it's more generally called the cubic function, so that's what I'm going to call it, which is f of x equals x cubed. Now, unlike the square function that makes every input either 0 or positive, when we input something into x cubed, you could get a positive, a negative, or a 0. It all depends on the input. Positive inputs give us positive values, 0 gives us 0, and negative inputs give us negative values. So we're going to have a point at 0, 0, 1, 1. If I plug in a negative 1, negative 1 cubed is negative 1. 2 is going to give me 8. So let's put that way up here. 2, 8. And negative 2, when I cube that, is actually going to give me a negative 8. Oops. Sorry. Negative 2, comma, negative 8. So our function ends up looking somewhat like this. The part in quadrant 1 kind of looks like a parabola. The part in quadrant 3 kind of looks like a parabola flipped upside down. But notice that this function is actually is odd. It has symmetry with respect to the origin. Its domain, all real numbers, and as I said before, because you can get positives, negatives, and a 0, its range is also all real numbers. The fifth function in the library of functions that you need to have memorized is the square root function. Its equation is f of x equals the square root of x. So when we input something, what comes out is the square root of that number. The square root of 0 is 0. The square root of 1 is 1. And we're going to skip any numbers that aren't perfect squares to make graphing easier. If I move to 4, the square root of 4 is 2. Recall that the square root is defined as a positive number, so we don't get any y values to the left of the y-axis, a positive or 0 number. Recall also that you can only plug positive numbers into a square root if you're talking about the real numbers. So our domain, or 0, our domain is 0 to infinity, including 0, and the range is also 0 to infinity, including that 0. Notice that it looks like half a parabola on its side. I kind of think of it as the lazy half of the parabola. The sixth and final, no, that's not true. There are 8. The sixth function that you need to know is called the cube root function. Its function is, or its equation is f of x equals the cube root of x. Similar to the cubic, but this time we're going to be taking the cube root of our inputs. The cube root of 0 is 0. The cube root of 1 is 1. The cube root of negative 1 is negative 1. Remember that you can take a cube root of a negative. And then, again, we want to plug in something that has a nice even cube root so that we can graph more easily. Let's choose 8. The cube root of 8 is 2. and the cube root of -8 is a -2. So our graph ends up looking like this, almost like the square root function in quadrant 1, almost. But we also get this other piece in quadrant 3. So again, this is an odd function and it has symmetry with respect to the origin. Its domain is all real numbers and its range is all real numbers. Okay, two more. The first one is the reciprocal function. F of x equals 1 over x. So for whatever input I input, whatever x I input, it's going to take 1 over that number. It's going to take the reciprocal of that number. We saw this in an earlier chapter 2 video, so you might want to go back and take a look to figure out why the function looks like this. I did an explanation. It is important to note that the function does go through 1, 1 and -1, 1. I'm sorry, -1, -1, because 1 and -1 are their own reciprocals. And also that the domain does not include 0. So we'll go up to -infinity, up to 0, not including it, then start again at 0, not including it, to positive infinity. That's because if we put 0 into the denominator of this function, we get an undefined value, or not a value, something that's undefined. And then its range is exactly the same thing. And that's because we have to leave 0 out of its range as well. That's because there's no way to get 0 as a reciprocal of any other number. You know, 0 doesn't have a reciprocal, so it couldn't be that. And then there's nothing else to consider. Okay, last function, number 8, we call the absolute value function, because the absolute value of x is its graph, or is its equation. F of x is the absolute value of x. Recall that the absolute value makes every input positive, or 0. And not only positive, it gets its same value. So in the first quadrant, this function looks very much like the identity function. But what happens on the x-axis, in the quadrant 2, when we have, not on the x-axis, pardon me, what happens in quadrant 2 when we input negative x values? Well, if I put in a -1, I take its absolute value, that gives me positive 1 again. If I take -2 and take its absolute value, that gives me positive 2, and so on. So it's actually not wavy. The function ends up looking like a big V. With slope, the right-hand side on the right of the y-axis has slope 1, and on the left-hand side has slope -1. It's like almost like two lines coming together. The domain here is -infinity to infinity, because we can take the absolute value of any number, and the range is 0 to infinity, because when we take the absolute value, the lowest value we can get is a 0. Okay, again, like I said, these are very important in calculus. Next time we will be looking at transformations of some of these functions. That's why you need to know them.